Hello everyone. Hope you're all doing great. Welcome to session 5 of the Corona rendering course. Today, we'll dive into interior and exterior lighting and analyze key techniques for achieving realistic results. We've prepared 2 separate scenes, so we can fully explore different lighting approaches. 2. Initial preparation and GI's role in scene realism. First, we begin with environment creation. As mentioned earlier, global illumination, GI, must always be active to ensure realistic and physically accurate rendering. GI is a core feature in physical render engines like V-Ray and Corona, enabling proper light distribution across the scene. 3. Understanding scene components and the importance of sky dome. The environment consists of 2 main sections. Sky dome, responsible for creating a natural sky. Sun, which functions as a direct environmental light source. Sky dome plays a critical role in achieving balanced lighting and can be created using multiple methods. Corona sky, natural sky lighting with new features, especially in version 7. HDRI images lighting based on real photographs. Clouding technique, manual sky color adjustments and gradual transitions. 4. Choosing the best approach for environmental lighting. Among these methods, the first 2 are the most widely used. Corona sky and HDRI images generally produce more realistic results. The clouding technique is helpful, but is used less frequently. 5. Removing extra lights and setting up the sky for scene illumination. At this stage, we remove all unnecessary lights to ensure better sky control. Next, we review existing windows in the scene, analyzing how curtains and mesh screens impact light entry. Now we're ready to proceed with environmental lighting using the sky dome setup. Rendering setup, lighting and exposure control. 1. Initial setup and render test. Before starting, a quick render check is conducted to ensure everything is set up correctly. The render resolution is verified to be suitable for testing. In this section, all environmental lighting is controlled through the environment settings, and we need full control over these adjustments. 2. Setting up environment in 3ds Max and assigning sky map. Inside the environment settings window, shortcut 8, 2 options exist for applying sky map. The default 3ds Max environment, included in scene settings. Corona Environment Map, a more specialized and accurate option for natural lighting. Both choices are useful, but Corona Sky typically produces more realistic results. To apply it, the sky map is selected from Corona's list and assigned to the environment for proper lighting distribution. Free camera framing and initial render. At this point, the scene is viewed through a custom camera frame that was previously set up. Then, the first render test is launched to see if lighting settings are functioning properly. This test ensures unnecessary lights are removed, leaving only the sky dome as the primary illumination source. 4. Using material editor and adjusting light intensity. To control light intensity, the material editor is used. The environment material is placed inside a shader ball. The instance option is activated to apply real-time changes. These settings allow precise light control without direct adjustments in the scene, helping users monitor lighting effects efficiently. 5. Exploring LightMix and exposure settings. LightMix is a powerful tool for adjusting light intensities, but may cause performance issues on weaker systems. If hardware limitations exist, users should opt for simpler lighting controls. One critical setting is exposure control, which is modified after LightMix application. This setting should be adjusted to post-processing exposure to ensure high-quality lighting control from the frame buffer without image degradation. 6. Examining sky model options in Corona. Corona Sky features multiple sky simulation models, with 4 primary variants available across older and newer versions. Each model impacts color, light intensity, and overall scene atmosphere differently. These models will be examined further in upcoming steps. Reviewing sky models and adding sun in Corona Renderer. 1. Choosing the right sky model. In earlier versions of Corona Renderer up to version 6, Hosek and Wilkie was the standard sky model. However, in version 7, PRG Clear Sky was introduced, offering the most natural and accurate environmental lighting. This model significantly enhances realism and is the best choice for simulating realistic skies. 2. Adjusting sky intensity for balanced lighting. In Corona sky settings, the intensity option allows users to change sky brightness. Increasing this value helps achieve more balanced lighting in darker scenes. If the scene is set to white, light and shadows become more visible. If certain areas appear dark or black, it's often due to curtains or window meshes restricting light entry. 3. Understanding turbidity and its effect on scene lighting. The turbidity setting affects the color and tone of skylight. It introduces a warm orange tint, ideal for exterior renders and sunset lighting. In interior scenes, its effect is less pronounced. 4. Adding sun to the scene and adjusting its settings. The sun in Corona Renderer is the most realistic and powerful light source. It adds depth and impact to scenes and helps simulate different natural lighting conditions. If not properly adjusted. 4. Adding sun to the scene and adjusting its settings. The sun in Corona Renderer is the most realistic and powerful light source. It adds depth and impact to scenes and helps simulate different natural lighting conditions. If not properly adjusted, it may cause overexposure or unrealistic brightness. Steps for integrating sun. Hide curtains and window glass to allow direct light entry. Adjust sunlight angle for a more natural effect. 5. Directing sunlight into the scene. Sunlight must be guided. 5. Directing sunlight into the scene. Sunlight must be guided correctly through windows to match realistic lighting conditions. In architectural modeling, the angle of sunlight plays a crucial role in creating realistic spaces. If the window faces the appropriate direction, sunlight will behave naturally, accurately simulating northern or southern light effects. Sun angle setup, target selection, and sky linking. 1. Adjusting sun angle and camera position. In Corona Renderer, setting up proper sunlight angles is crucial for achieving realistic scenes. There are 2 standard sun angles. 45-degree angle, creating softer shadows and a more natural light spread. 90-degree angle, generating stronger and more direct illumination on the subject. Using top view, the Corona sun is added. Then, switching to perspective view, the sun height is adjusted to fine-tune. 2. Selecting the target for sunlight. After adding Corona sun, the first setting to check is the on/off state. The second important setting is target selection, which must always remain active to properly define sunlight direction. To select the target easily, right-click the light and choose Select Light Target. 3. Using Exclude to control light impact on objects. Sometimes, direct sunlight can cause strong reflections on glossy materials like marble floors, reducing render quality. In such cases, the Exclude option is used to prevent specific objects from receiving direct sunlight, improving overall lighting balance. 4. Linking sky to sun for automatic adjustments. Normally, Corona sky is manually added to the environment settings, but a better method is to link sky directly through Corona sun. This allows sky color and brightness to dynamically adjust based on the sun's elevation, enhancing natural illumination consistency. 5. Controlling sun elevation and its effect on light color. Lower sun elevations result in warmer, orange-tinted light, mimicking sunset conditions. Higher sun positions generate whiter, brighter light, similar to midday sunlight. These adjustments provide better atmospheric control, enabling more realistic lighting results. Sunlight setup, render testing, and LightMix overview. 1. Setting sunlight for interior scenes. Since we don't have an exterior scene, we apply Corona Sun for interior lighting. Sun positioning is carefully adjusted to allow natural-looking light entry through windows, ensuring realistic illumination. 2. Executing test render and fixing overexposure burnout. After configuring sunlight and its angle, the first render test is performed. If the image appears overexposed or burned out, 2 fixes are applied. Reducing sun intensity for balanced lighting. Adjusting sky intensity for softer environmental light. 3. Adjusting shadow softness in sun settings. A crucial adjustment in Corona Sun is shadow sharpness, sun size, which defines how soft or crisp the shadows appear. Lower values create sharp, well-defined shadows. Higher values generate softer, more natural shadows. 4. Using camera lock and frame buffer for lighting control. To maintain consistent lighting, lock camera ensures no unexpected scene jumps when modifying light properties. Then, IPR interactive photorealistic rendering is activated, allowing live adjustments without needing full re-renders. 5. Modifying sun angle to simulate sunset. Reducing sun height shifts lighting toward sunset mode, making warm, yellowish tones more prominent. These effects are controlled using sun height, turbidity, and sun intensity settings. 6. Understanding LightMix and its role in real-time adjustments. LightMix is a powerful Corona renderer tool, enabling light modifications without re-rendering. It is highly useful for controlling artificial lights, sunlight, and sky intensity separately. Through LightMix, individual light sources are displayed in the frame buffer, allowing precise manual adjustments within the render process. Adjusting LightMix, artificial lights, and Corona light settings. 1. Full light control using LightMix. Once LightMix is activated, all scene lights become fully adjustable without requiring re-rendering. The first step is to modify natural lighting, followed by artificial lighting. Using LightMix, settings for daylight, nighttime, and sunset can be stored within a single render and later adjusted freely. 2. Exploring artificial lighting in Corona Renderer. In Corona, only one primary artificial light exists, Corona Light. This light is highly customizable and can be assigned to various surfaces. To create light, Corona Light is activated and applied via drag and click on the target surface. 3. Using target selection to guide light direction. Artificial lights can be assigned a target to refine their directional behavior. If no target is specified, light will spread evenly in all directions. To achieve precise control, target mode is enabled and directed toward the desired subject. 4. Adjusting light intensity and units of measurement. Corona light's intensity can be modified via LightMix, eliminating the need for manual intensity adjustments. Light measurement units can also be changed. Lux, standard brightness unit. Lumen, visible light intensity unit. Candela CD/M2, unit for surface light intensity. 5. Shadow control and final render adjustments. Some light settings impact shadow realism and rendering quality. For example, adjusting shadows within IPR allows users to observe different results. In darker environments, fine-tuning artificial lighting and blending it with natural light enhances overall realism. Adjusting light color, light models, and light lister. 1. Modifying light color and using Kelvin. In Corona Renderer, light color can be precisely adjusted using Kelvin settings. A 6500K value produces pure white light, while lower Kelvin values create warmer, yellowish tones. Higher Kelvin values shift the light toward cooler, bluish tones. Ideal light settings. Warmer light, below 6500K suits indoor spaces requiring cozy, relaxed lighting. Cooler light, above 6500K, fits modern environments and bright daylight simulations. 2. Choosing light models and their scene effects. Corona Light offers multiple light models, each influencing the scene differently. Sphere light, best for lamps, chandeliers, and ambient lighting. Angle light produces focused, directional beams useful for spotlights and stage lighting. Disc light, typically applied to ceiling lights and panel lighting. Increasing segments ensures a smoother, rounder light shape. 3. Adjusting light angle and beam spread. Setting the correct light angle is critical for realistic illumination in Corona. To precisely direct light, use rotate to adjust light direction. A 45-degree angle creates softer shadows and natural lighting. Spread angle controls whether light is concentrated or diffused. 4. Exploring Light Lister and managing light sources. Light Lister is an advanced tool that displays all scene lights with detailed parameters. Users can modify light intensity, color, instance settings, and light type from a single interface. This tool simplifies light adjustments without requiring manual selection of individual lights. Adjusting artificial lights, visibility settings, and IES lights. 1. Controlling artificial lights in LightMix. One of LightMix's most valuable features is full control over artificial lights. If lights are instanced, only one version of the light appears in LightMix. However, using Make Unique, each light can be individually modified. 2. Configuring visibility options for artificial lights. In Corona Light, the Visible Direct setting determines whether the light source itself is visible. If enabled, the light source is physically present in the scene, but if disabled, only its illumination effect remains. This setting is particularly useful for hidden light sources or embedded fixtures like chandelier bulbs. 3. Adjusting light effects in reflections and refractions. The Visible in Reflections option affects whether a light appears in reflective surfaces. If enabled, the light contributes to reflections, but if disabled, its illumination remains without appearing in reflections. This is commonly used to eliminate unwanted highlights in glossy materials like polished marble. 4. Managing IES lights and their application in scene design. IES lights are predefined lighting profiles provided by lighting manufacturers. These profiles include specific light beam patterns, allowing for precise lighting control. Using IES lights, users can add industrial lighting, ceiling-mounted fixtures, and specialized architectural illumination to their scenes. Working with IES lights and multi-light mix. 1. Introducing IES lights and their application. IES lights are standardized light profiles provided by lighting manufacturers. These profiles contain preset light beam patterns, enabling users to implement precise lighting in interior and exterior designs. To use IES lighting, IES files need to be loaded into Corona Renderer. 2. Loading IES files into Corona Light. Steps for adding IES lights. Accessing the IES light list from Corona Light settings. Selecting and loading an IES file from saved directories. Reviewing variations in light patterns and choosing the appropriate style. Once loaded, the light is automatically applied in the scene and becomes visible within IPR for adjustments. These configurations include intensity, direction, and placement. 3. Adjusting light intensity and color via LightMix. After integrating IES lights, LightMix allows users to fine-tune intensity and color. This capability enables modifications without requiring re-renders, making lighting workflow smoother and more flexible. 4. Optimizing IS light positioning in the scene. Sometimes IS lights don't display correctly, usually due to improper placement within the scene. To resolve this, modify the light target to ensure proper orientation. Adjust the height for correct wall or floor illumination. Increase light distance to improve visibility and coverage. 5. Exploring multi-LightMix and its features. Multi-LightMix is an incredible feature in Corona Renderer, allowing users to combine multiple lights with different moods and atmospheres. It enables simultaneous management of environmental and artificial lighting, letting users define distinct profiles for various lighting setups. In the next session, we will explore combining HDRI images with multi-LightMix to achieve professional and fully controlled scene lighting. Hopefully, this session was beneficial in enhancing your professional lighting skills. Okay, we have reached the end of this session, and we covered all the important points. Be sure to practice and repeat these features so that you are prepared for the next session. I am Behrouz Bigham from the Architecture and Graphics Simulation Studio. Have a good day.